Hi, Rancher Conference. Thank you for joining us for our presentation on using Kubernetes for edge AI operations, such as artificial intelligence at the edge. I'm Ryan Lucky.
And I'm Alex Payne.
To start things off, we wanted to make sure that we were on the same page regarding what we mean when we refer to artificial intelligence at the edge. For those of you who are familiar with the Internet of Things, or IoT, there will soon be over 63 billion devices in the field. And we feel, and the industry seems to be agreeing with us, that by taking some of the things that used to only exist on the back end, such as cloud or on-prem, and being able to push more of that functionality to IoT devices, sensors, wherever it is that the action is happening, we have the ability to decrease bandwidth requirements, increase responsiveness, and potentially even save lives depending on the application. Next slide. Some of the use cases that we've been addressing when we have been tackling some of these proof of concepts that we've been developing regarding artificial intelligence at the edge seem to target vision analytics. This is because traditional IoT-based computing systems struggle when referring to image and video-based analytics because of the sheer amount of data that has to be transported and analyzed. By shifting the model to where the devices themselves are able to filter out the data that's not necessary, we have the ability to save time and save money for the applications of this technology that we're looking at. These particular models, in fact, were based off of a series of libraries from our partners like Intel Corporation, Google, and Nvdia, who have released a large number of open source models that we've then been able to tailor to meet the requirements of our clients. In fact, we have over 150 different models that we are able to draw from so far. We have, based off of our current observations, been able to find that these are highly performant and are capable of inference speeds as fast as 15 milliseconds, or roughly the blink of an eye. Next slide, please. How we end up deploying these is through a mixture of open source and custom-built technology. As the name of the presentation implies, Kubernetes is central to how we deploy and manage these AI models that we are deploying to these devices. Going through the regular data ingest, data training, containerization of these models, and then deploying them, we found that we can create a portable, incredibly scalable solution.
Yeah, and thank you, Ryan. And just to provide more context on that and how we're a deeper dive into how we're using K3S in our solution, specifically Kubernetes and Docker containerization, is we're utilizing our cloud platforms to train production-grade AI models for vision analytics across the variety of use cases that we highlighted in the prior slide. And what we could do is through Docker, we can containerize these models, and then through K3S, installation of a master node in our Kubeflow environment within our cloud environment, we're able to then install agent nodes, Kubernetes clusters on our edge devices and sync them back with the master node so that we can then shell into our edge device fleet as long as they're connected to the internet. And how this is powerful is it allows us to have a streamlined process of Kubernetes management across all of our edge AI models to scale up to be able to manage an entire fleet of edge devices and shell into them and press a button and have your entire edge device fleet be updated with those new models that you're trying to run. And so that's just kind of a high level understanding from this visualization of how we're utilizing Kubernetes and multi-cluster managers to really drive that impact and instant mission critical insights. So next, we'll go ahead and go on to our demos. And what we'll be showing here is several selected use cases of where we're running AI on these handheld edge devices, such as the Raspberry Pi, the Intel NUC, the Nvdia Jetson line of products, and utilizing these USB accelerators that you can plug into existing hardware to make it more AI powerful and be able to run and achieve that 15 millisecond inference speed on the device. So the first selected use case we'll go through right now is protecting workers from restricted or hazardous areas. So we'll go ahead and play this video. And what you're going to see here is that as I'm stepping into the frame of this edge device with a camera attached to it, it's detecting that I'm in this restricted or hazardous area. And that was all executed with very fast precision on that edge device itself. And we can tie that in with various Python APIs and through our cloud platform, automated workflows where, say, somebody steps in that dangerous area, it's already shutting the machinery down instantly, or it's already sending a text alert to the supervisor to know that that person needs to be reprimanded or shown the right way of handling their safety on the workforce. And so demo number 2 is tracking foot traffic in hotspots in smart buildings. This could be very much utilized in the COVID-19 situation nowadays of understanding how many people are flowing through a particular area. Are they socially distanced? Are they wearing a mask? And so then with these AI models running, we can detect how many people have stood there for how long. This could be utilized for a variety of retail situations where you have a large line waiting to get customer service and such like that. And you can use it for wait in line analytics. So then use case number 3 is providing real-time AI insights on a pair of wearable AR smart glasses. So we took a pair of smart glasses and we utilized our USB accelerators, such as the Google Coral USB accelerator, which has an edge TPU on it. And we were able to take that existing piece of AR smart glasses and we were able to run AI directly on that pair of glasses itself. So what we'll show you here is on the left here, you're seeing me wearing that pair of wearable smart glasses. And what you're seeing to the right there is the thumbnail reticle of what I'm seeing on the glasses. And it's running this AI object detection right as I move around the room, real time on the device itself. This could be utilized for a variety of training augmentations and on the job type trainings, so that, say, that new person on the workforce is getting the most up-to-date trainings. They're getting an AI-assisted trainer that's helping them spot where they messed up so that they can go back and fix it. They can learn the situations and become a better worker. So demo number 4 is detecting objects to identify worker safety. And so we'll go ahead and watch this one. And this is all happening on one of the Intel NUCs that we've gotten our models to run on. And what it's doing is it's looking for a variety of objects such as person detection, safety vest detection, hard hats. And it's actually catching people that aren't wearing those proper safety gear for compliance metrics. And this could be very useful for a variety of sectors, from not only just worker safety, but to worker compliance. Is your workforce wearing the PPE or the mask for COVID-19? Are people socially distancing? And so with that in mind, we'll go ahead and go on to demo number 5 here of detecting flaws in production lines. And what you're going to see here is a model running on one of these edge devices that is running anomaly detections and spotting flaws in this production line of these bolts. It's detecting cracks, discolorations, orientation defects. This could be huge in a predictive maintenance use case of spotting flaws before they go into production, so that you decrease risk of breakage or being shut down for hours. And in terms of that, it increases efficiency. And so with that in mind, those were just some demos that we've put together and that we've developed internally. all in this effort of managing these edge AI devices and managing fleets of these devices, all performing a particular function. So with that in mind, we'll go back and take a step back from, that was kind of the last mile solution of those edge devices running the AI on the device itself. Let's take a step back and kind of look at behind the covers of the backend of our cloud-based platform. And so this first video that we'll be showing you is just kind of an overview of the guided user interface, the web interface of our application that is multi-hybrid cloud. We've been able to plug in GCP and AWS, and we could also plug in Azure fairly easily as well. And what this allows is it allows a centralized platform for you to pull all of the tools that you want across your favorite cloud providers. So say you would rather use AWS SageMaker than Google's AutoML, or you would rather use AWS Greengrass than GCP's IoT Core. Our platform, through its multi-hybrid cloud integrations, allows you to pull together the architecture that you truly need to get the mission done. And so with demo number 2 of this backend, we'll kind of go through network graphs and fleet observation and some stuff that we're currently working on at Deloitte. So what you're seeing here is an Istio service mesh of a deployed full-scale application that's in production at Deloitte. And what you're seeing here is that all the nodes and how they're all communicating with each other to, basically serve that application. What we're working towards with our edge AI devices fleets is that we will be able to create Istio service meshes like that, but your entire scaled up enterprise level edge device fleets, so that you can see when an edge device just went down, see how that edge device is communicating with the swarm of edge devices that you have in your inventory. So with that in mind, let's take a real live use case that we're currently working on as a proof of concept. And we as a team and an edge AI team have built a custom drone from scratch, a 6-rotor drone. And the reason we did that was so that we could make it as customizable as we wanted, so that we could outfit it with a variety of edge devices, and we could fly autonomous software onto it, and have the drone fly itself. And so what we do is, since this edge AI prototype we built can be powered by a Raspberry Pi, Nvdia Jetson, we can push that K3S agent node cluster onto those edge devices, sync it to our cloud-based platform, and then you have the ability to shell into this drone and deploy a new AI model to that drone to then go fly its mission. And then we've been working through open source autonomous flight software such as Autopilot and Mission Planner and APM Planner to basically trace flight paths and program autonomous features onto this drone, so that you could access this drone remotely and have it go look for, say, anomalies, which is highlighted by this use case. And so here's an example of where this drone could either be pushed the new Docker container of, say, that anomaly detection model. Then you can either launch this drone manually through a remote control or autonomously through your computer communicating with it. And then this drone flies off on its flight path, say around your infrastructure anomaly. And then we've trained up a very accurate model around infrastructure anomaly detection to spot the breakage and wear and tear on electrical infrastructure. And then the idea is that that drone then sends that instant curated alert, did all the work for you instead of having to stream all that data to the cloud. And then you're able to get real-time critical infrastructure detection alerts to your cell phone, to your emails, so that then those people are going out and fixing that immediately. So with that in mind, I'll turn it back over to my colleague, Ryan.
Thank you, everyone. I hope you have enjoyed our presentation on using Kubernetes in an edge-based environment.
Thank you so much.